Hey everyone, welcome to my channel. Today I'm gonna tell you 8 simple steps to master geometry in Revit API. And before getting started, if you find the content useful, please like this video, subscribe to the channel, leave any suggestions in the comment section below, and turn on notifications. So I know that this topic is quite confusing and frustrating at first, because working with parameters only requires some C# skills and of course a bit of Revit API skills, but first of all, it's really easy to notice if you messed up. It's really easy to understand whether you have done something wrong. So for example, if you take an element from Revit and you get any parameter that you want to set, and you set it via Revit API, and then you go to Revit itself and check the value of this parameter. And if that parameter has been changed, then you've done everything successfully. But what about geometry? How do we know if we are at the right path? If we are really getting what we think we should be getting? Let's see, for example, you want to build your room finish plugin. It's actually a lot of tasks there are a lot of tasks need to be done to actually make it happen. It requires a lot of geometry analysis and again, a lot of steps to be done to get what you want. And you want to be able to check if you're not making any mistakes at some point throughout the development, because that is really crucial if you have a lot of geometry analysis. At some specific points, you want to be able to check if you are heading towards the right solution, if you're actually thinking the right way in terms of solving the given problem. So actually, this is the place when it can get frustrating. And with these 8 steps, you will be able to master geometry in Revit API and solve any kind of problems. And actually, currently I'm building a complete detailed course about Revit API that's going to be posted on my Patreon. So stay tuned to be notified when it's released. So let's kind of get to the steps that you need to follow. So here I've written down 8 steps for you to master this. And the first one is learn about vectors and points. I think that is the first topic for you to get going with, because that is like the basics of geometry, especially in Revit. Right, so here I've typed down some of the comments that I'd like to tell you. So the first one, understand what are the main properties of it. So if you go to the Revit API documentation, right, so now we can combine this with Revit API documentation. So for example, if you go to the XYZ object, uh, which is the object for points and vectors, you simply need to start with understanding what are the main properties of this. What are the main things that you need to pass to create that object? And actually, it's 3 coordinates, X, Y, and Z. So let's go back to the slide. So for all geometry objects that you want to master, you need to understand what it consists of, what properties are crucial for this object to, to just be created. But as you can see here, I've typed vectors and points, and I just showed you only like XYZ object. So in Revit API, vectors and points are represented by XYZ object. So if you came from Dynamo, that can be really confusing for you because in Dynamo we have an object for point, which is called a point, and we have an object for vector, which is called a vector. But in Revit API, it doesn't work that way. We have only one object, which is called XYZ, and it can be used as a point, and that can be used as a vector. So it's vitally important for you to just get started with understanding what is the real difference between a point and a vector. So you have these three coordinates, x, y, z, and how does this affect my, for example, Revit elements if I apply to them these coordinates? So a great demonstration for that would be changing the location of your element, especially a point-based element, right? And then change it by element transform util class by method move element. So if you go to Revit right here and you have any kind of like elements, for example, a table, right? You can just try to change its location. For example, change it by the point, so by having here, and change it by the vector, and try to, for example, move it to the same place, but by using two different methods. So the first one will be changing the location of the element because each element has the location property. And the second one will be by using move element from element transform utils class. Try to do two same things by applying two different methods to this. And that will help you understand the difference between them, which I think is one of the most important things when you get started with vectors and points. When you're just kind of comfortable with simple manipulations with points and vectors, when you know at least what a vector is, you need to look up the usages of cross and dot products. Because by knowing that they are there, it's not gonna help you. So if I go back to my documentation, here we have a lot of methods. And to be honest, all of them are quite important. But cross product and dot product will give you a lot of options to interact between to have some interactions between two vectors. Some of them will give you just some double, just some value, and some of them will actually give you another vector. So what do I mean by that? Is that by looking up some usages, you will be able to learn this only when you have and only when you see real examples of it. So that is really crucial for you. But believe me, these two methods are crucially important. You need to get familiar with them and look up some examples. Where you can find these examples. I've created a video about vectors, and you can find a lot of applicable things out there. I've created a video about vector, about a point, the difference, about cross and dot product. So make sure to check them out. Also, how I learned them and where have I looked up the information, that was the videos and some examples from Unity. So Unity is a cross-platform game engine, and there are actually a lot of great things that can be done with geometries out there. So they're in games, they use geometry a lot. So I kind of check it out and I just see some examples. I didn't care about the code for gaming. I just cared about the examples, about the usages. That was really important for me. And here I've just typed some really simple usages. For example, cross product will give you perpendicular vector between two vectors. And dot product, actually, it gives you a lot of things to do. But two main things that I talked about in my video is that it allows to compare two vectors. It allows to measure distance between points along a given vector. It allows you to project a point onto a plane and more. There are a lot of usages for this. But here you really need to kind of go step by step and start by understanding what a vector is. And nobody stops you from going even to Dynamo Primer and to see what a vector is from their website because they're visualizing this really in a good manner. So you can even use Dynamo if you want. If you came from Dynamo, nobody stops you from combining learning about geometries with Revit API. but I think that we can actually make that process easier, and I'll tell you how on one of these steps. So to sum it up, the first step is to take your time and make sure that you learn about vectors and points. You know what is the object we use, what is object that we use for doing any kind of manipulations with it, and where that can be useful, and learn different usages for this. But of course, make sure to not stop. Don't let this thing stop you from moving to the next topic, because sometimes you cannot get everything right off the bat. You need some time to see the usages for this. The second step is to understand what a solid is and what it consists of. So a lot of problems that you will have actually and that you will need to solve will require some geometry analysis. And if you go to Revit, I really think that that is quite cool for us to understand what a geometry in Revit is. You know, Revit is a program that deals with geometry, right? Everything in Revit is kind of like geometry. Not everything, but what we model is some kind of geometry. So you really need to think of this as just some solid geometries. So everything here is a solid geometry. You can look up more about solid geometry, but here the most important thing for you to understand is what it consists of, because by knowing this you'll be able to analyze it easier and get what you actually need to get. So for example, here we have uh, by exploring this topic you will understand that all geometrical objects derive from geometry object class. So for example, if I go back to Revit API documentation and look for solid, here I have a solid class, and I look at the hierarchy, here the first one will be geometry object. And here, as you can see, everything inherits from it. So curve, edge, face, solid, everything inherits from this. So as you can see, there are a lot of hierarchical elements out here. So this is why it's really important for you to understand the solid itself, because it may contain other geometry objects in it, and that it actually contains. So for example, that is what we have. We have solid, so that is kind of any geometry in Revit that we have. Solid consists of faces. So basically you can get faces out of one solid. Out of these faces, you can get curves. Again, I'm not talking about some useful properties such as like different kind of directions, normals, and all of this stuff. I'm just talking about geometry objects right now. So it has faces. From faces, you can get curves, and from curves, you can get points. By knowing this, you'll be able to get what you need from some specific solid element, right? So you'll be able to filter faces that you need. You'll be able to do more analysis, and that will help you solve tons of different problems related to Revit geometry. So to sum up this portion, you just need to take a Revit element, get it solid, and try to analyze it. Try to get some specific faces. From these faces, get some information. For example, get its normal, then get its curves. From the curves, you can get points, and you'll see how from the points, just some simple points, you can go to the solid, and that will help you uh, in analyzing geometry objects. The next topic can be quite complex. It's a transform. You can think of a transform as a coordinate system. Again, if you came from Dynamo or even in Revit, we have coordinate system. And transform, this object allows us to perform different kind of transformations with our geometrical objects. For example, think of the scenario when you need to move your geometry objects. For example, you have a solid and you want to move this or you want to rotate it. So transformation can be quite handy here. And that goes for a lot of geometry objects like curves, points. You can also apply transformation to the point. So you can have this coordinate system and in some way, like somehow you can manipulate the location, the transformation of the element of some solids, of any geometry object, and you can change their location, the way they're represented. So that can be also quite handy. So the first one is to move your geometry. Also, you can retransform from family instance. Again, transform is just like a coordinate system, right? Again, it requires for you to kind of go and look for the main properties for it. I really believe that, especially when it comes to geometry, that to master it, you need to start with understanding what are the main stuff that transform cannot exist without, right? So you just simply go and then, okay, my transform has, for example, three vectors. Like, what are they responsible for, right? So that is for you. Like, now we're going through some steps that you need to follow, but definitely you need to search for these topics on your own, like to master all of them. There are a lot of them on my channel so far, but all of them will be on my channel. Uh, and I stopped on read transform from family instances. Why that can be so handy? Because actually, in Revit, we build our families in a completely different environment, right? So we have our document, our project document where we're working with our project, but we're building families in a different environment, in a different document, and it has its own coordinate system. It has its own transform. And when you load it and place it in a project, it's placed relative to the Revit global coordinate system. So if you notice that Revit has its own global coordinate system, so if you go to visibility graphics and you go to site, here you have internal origin, and if you apply it, you will see that here is your global coordinate system, which is immutable, that cannot be changed. And all objects are all families are placed relative to this coordinate system, and you can read the coordinate system from each family instance. That can be quite powerful. Maybe now you don't see like the application for this, the applicable parts for this, but with time you will understand how powerful it is and what actually information you can read from it. And the third one is to apply transforms to bounding boxes. That is some topic that we will get to when we go to bounding boxes, but that is also quite a powerful thing. Just when you get to these, when you start learning this, make sure to go through some stuff that I've written here and try to ask yourself whether you really understand what uh, what each point actually means here and if you understand the gist of it. Now we go to the mastering bounding boxes. So far, you know about vectors, you know about points, you know about solid, what it consists of. Now you also know about transform, and actually to know about a transform, you really need to be um, cool with vectors, so and points. So that is why I give you this in this kind of hierarchy. And now, when you're cool and you're confident with transforms, vectors, points, you can get to bounding boxes. Because to actually master this, you need to learn all of these topics. First of all, there are a lot of filters related to bounding boxes. For example, bounding box intersects filter. So that can be quite helpful as well. We're not going to stop on all of the filters that Revit has, but imagine that you have some elements in Revit, right, in your Revit document, and you have some bounding boxes, and you can actually filter elements which intersect with a given bounding box. So isn't that cool that Revit can do that filtration for us? We don't need to actually get some geometry from the bounding box and do intersection checks. Revit can do this for us. So make sure that you're familiar with what Revit has on offer. Actual Revit API has on offer. Then it allows you to master view creation, especially sections and elevations. And I think working with sections and elevations is a great thing for you to master bounding boxes. Because, for example, if you take a section into consideration, you can, like, and if we compare it with the floor plan is a really simple one, right? But sections can look up, they can look upwards, downwards, forward, they can look backwards, they can have different angles, right? And they are built based on a bounding box. So when you create a section or elevation, you need to pass a bounding box as a parameter in it. So this is where you will be able to master the bounding boxes and understand the whole purpose of this. And to be honest, for you to master it, what you need to do is to understand the meaning of this. That is a box, right? A simple box. So what you can do is that you can go to Revit and create a simple family representing a box, right? And load it to Revit. And then you need to go and check out the main properties, the main characteristics of the bounding box. And you will notice that you need to have a minimum point, a maximum point, and a transform. So these are three main characteristics that you need. So if I go to Revit and simply show you quickly what it is. So let me represent this box by having just a rectangle, right? So that is the family that you've built, for example. We have minimum point and we have maximum point, right? So basically here, it makes sense that 2 points are enough for this object to be built. So basically you can say that if you have a point here on the left bottom corner, and if you have a point on the top upper corner, that's actually enough for the box to be built. But what if you rotate this box, right? So for example, if you want to get the rotated box, right? So if you get two of these points, it's not actually this kind of box that we get, because again, if we build a rectangle, that is going to be something like this, right? If we think about this. So minimum and maximum points, they're responsible for box dimensions. But for the rotation, that is where transform comes into play. So bounding box will allow you to solidify your learning about transform and how it affects particular elements, especially bounding boxes. So you will ask yourself a simple question. What are minimum and maximum points responsible for? They're responsible for box dimensions, but the transform is responsible for rotating this. So now if we know that coordinate system of this box, for example, the x goes there, the y goes there, so minimum and maximum point will be within this specific coordinate system. I know that it can be quite complicated right now, but if you really go through this and try to build it on your own, you will be able to master this. So let's go back to the presentation. Uh, so actually, yeah, there are tons of great usages for bounding boxes. It's not just about creating something, but it allows you to simplify complex geometry, because bounding box is a box, right? And usually almost 99%, you don't need to go to get the detailed Revit geometry. You just need to have this box. Even when we check for intersections, it's enough for us to get just the box of this. So really think about this, the usages of it, when that box can be helpful. Try to analyze it, try to play around with this. Now we come to master planes. And to be honest, if you are cool with transform, planes are going to be a piece of cake for you. But also, you can draw an analogy with work planes in Revit. So if you're confident with Revit and work and reference planes, work planes, and all of that stuff, it's gonna be not that complicated for you. But also, you need to kind of learn how to visualize this, and that will be my seventh step. But as I told you here, if you master a transform, a plane is not gonna be difficult for you. And uh, like a usage for this can be when you want to create a model line in Revit. So you know that a model line, that is a 3D object, right? So here I have a model line, it's located here. It's a 3D object, and we know that in Revit, all 3D objects are dependent, they rely on a plane that they are going to be built on. So here you can go with the plane of the level or pick any of this. So that element should be built on a plane. So here, when that can be useful, imagine that you have some wacky planes with different directions, like not different directions in terms of that it's a 3D space line, a 3D space curve. And to create a model line from it, when you want to visualize it in Revit, you need to place it on a plane. So that would require for you to go there and write your own method to place any curve onto a specific plane, or get a plane that a curve lies on, and all of that kind of stuff. So that can be quite useful. But to be honest, they're quite similar, like transform and planes. Of course, they have different properties and options, but transform are way much that gives you more flexibility. With transform, you can have some rotations and do all kind of wacky stuff. With planes, there are not that much of options, but you can easily swap between each other. So what I mean by that is that you can create a plane out of transform and vice versa. So it's really easy to kind of work with transform and at some point tell, you know what, now I want to create a plane out of this. So that can be also quite handy. What is also quite an important topic for you is to understand cool features. Okay, there's a mispronunciation there, misspelling there, features. Understand cool features of different geometry object classes. And what I mean by that is that here we have these different hierarchies. Let's go to Revit API and see what do I mean here. That here we have a hierarchy of geometry objects. So we know that geometry object, that is like the base class for all geometries that we have. And if you go to curve, right? So curve inherits from geometry object. So curve is a geometry object. So if you go here to the hierarchy of the curve, you can see that arc inherits from curve, cylindrical helix inherits from arc, and so on. It doesn't like if you go there, you can see that it inherits actually from curve. I'm just showing you the hierarchy that we have here. It's really important for you. I'm not telling you that you should build each of this. You should just look at the properties and kind of it will give you an idea of it will give you like a picture of what it has on offer, and sometimes some of the properties can be quite useful to use. So make sure to go through the hierarchy and see what you want to do with this, right? How that can be helpful in any scenarios. Now, what is quite important is to how to visualize your geometry in Revit environment. No, this is what I talked about when I gave you an example of like building your room finish plugin. It requires a lot of analysis, and at some points in time, you'd like to check if you're doing everything right, right? If all of your thoughts are actually correct and all of your ideas are actually heading towards the right path. So here, you need to learn how to visualize each of these geometry. So first of all, how this process goes, like how I'm approaching learning geometry. So first of all, I just get familiar what it is, right? I go and I read about this. I go and search for some examples. I learn about different properties of this without actually working with it, just understanding, just reading and having like these general idea of what that object represents. Once I understood the main properties of this, for example, if we're talking about a transform, it consists of three vectors, like that they define the directions of each of the vector of the transform, right? Each of the directions. So if I go to Revit, right? So if I go back to Revit and I go to 3D, that is my transform. That is my global coordinate system. And I decided to visualize this the same way Revit does this. Of course, without these arrows, I didn't need this. I just simply created three lines and color them, right? This one X in red, Z in blue color, and Y in green, right? So I always try to visualize this because that'll make it easier for me to understand all these objects. So when you get started with vectors and points, make sure you simply have a general idea of what that object is. Then you learn how to visualize it and then you play around with this. And that goes for each geometry. So if you go to transform, understand the main parts of this, then visualize it. And even if you are wrong in visualizing, later on you'll understand that you messed up at some point. But that way you will be able to master this and will be able to have some like you'll be able to have a look at your development process, like when you're developing your plugins that has when you're developing your plugin that has to do with a lot of geometry, you'll be able to have this kind of like snapshots at some points and checks if you are actually right. And the last part, and I think is a really crucial one, is to analyze geometry of Revit elements using Revit Lookup. Actually, it doesn't mean that Revit Lookup should be used only for this kind of scenarios. Revit Lookup is an amazing add-in for you to use and to analyze any kind of element in Revit. So let's gonna see what does it look like. So for example, here I have an element, I have a desk and I want to analyze each geometry. So I basically go to a Revit lookup. So I have it here. You'll be able to access this via add-ins, and here I have Revit lookup. Of course, if you've installed it, right, you go to snap current selection, and here it gives you full, not actually full, but a lot of cool features that that element has. For example, we can access its geometry, right? So you go through the hierarchy. Right now, I'm not gonna explain this in depth, and actually, I have a video about this, so make sure to check this out if that is released, because I've recorded this already, but I'm not sure if that is gonna be released before that video. So here, let's say you go through the hierarchy, and finally you get to this solid geometry, right? So here, by clicking on the solid geometry, this is what you can get. This is what I talked about, that your solid consists of faces. So you can go to faces and see what kind of faces do you have. And out of faces, you can actually get curves, right? So here you can get curves. And right here in Revit environment, you can actually analyze what properties that that curve has. For example, that line has the direction of this vector, it has its origin, and a lot of cool features, right? So this is the way for you to analyze any kind of element in Revit and see like some geometrical stuff that is important for you, right? So this way you can troubleshoot, you can solve your problems in a quicker manner because you're not only getting familiar with the what it has on offer, like what kind of properties the solid has, but you can actually check what these properties are giving you. For example, here you know that now your solid has the property of faces, but you can go to these faces and analyze some of the like information about this, right? So for example, here you can analyze of the planar face, you can analyze some x and y vectors, face normals, origins, and a lot of cool features, right? So that can help you a lot in your development process. So make sure not to neglect them because omitting these things will make your life a little bit harder. So that's it for this lesson, but what I want to talk about right now is that what are the takeaways from it, right? I've told you a lot of cool features. I've told you the steps that you need to follow to master geometry in Revit, but what are the main takeaways? So first of all, there are a lot of geometry in Revit. So don't beat yourself up for not knowing all of them. You know, that's okay. There are a lot of them, and it takes some time to get familiar with not even all of them, but at least the most important ones. The second takeaway is to take your time and make sure to go through each topic. You know, really take your time and play around with points, with vectors, understand the difference between them. And when you feel that now you don't have anything to learn, maybe. I think nowadays there are a lot of resources for learning more. But at that point, you can go to another topic, and when you learn about like solids or transforms, you will solidify what you've learned before. This is why I gave you these steps for mastering geometry. And the most important one, play around with this. Have fun with this. Like, make sure to allocate some time for just having fun with this. You know, create some cool plugins that do maybe even some stuff that is not relative. Build your own game in Revit API. That can be quite funny. That you can actually master Revit API geometry with building a game within a Revit. You know, it's not going to be like a real game, but you can try to come up with some crazy ideas that can help you a lot in your development process. So that's it, guys, for this lesson. Thank you for watching. If you find the content useful, please like this video, subscribe to the channel, leave any suggestions in the comment section below, turn on notifications, and have a nice day.